Hey everyone, we got our 11-2 day 2 worksheet here to go through. And so I'm going to start with problems A and B. We've got a list of data here. And right above it, you can see kind of the terms that we need to be thinking about here for this unit. Measures of center, which is mean, median, and mode. And that's like your typical data point. Okay, measures of spread, range and standard deviation. How spread out is the data? How much does it vary? Variation, measures of variation is another one. And in 11.2, we've got our box and whiskers, which introduced quartiles like Q1 and Q3, the interquartile range, and we don't have that yet, so don't worry about that. All right, in problem A, we've got a set of data. We're asked to find the mean, median, and mode. We can do that, at least the mean and the median, on our calculator or on Desmos. We're going to do this on Desmos here, and you can pause the video and do that yourself, or we can get it typed in here. But what you'll see here is that as we get the data typed in, we can then use that function or just type in the word mean and type in x1, and we get that our mean is 12.928, 12.9 we'll call it. And we can type in median, and we can see, well, we can almost see, we can see that the median is 13.5. Another thing you'll notice, though, is that mode isn't one of the choices. So we actually have to look and find the mode. Let's see, we have 2 8s, we have 2 12s, but we have 3 17s. So that's our mode, 17. Okay. So those are 3 ways to kind of describe the typical data point. In B, we can use the data to find and create a box plot, to make a box plot. So, okay, we got to look at a few things here. We've got our minimum, that's easy to find, it's 5. The maximum is 20. And the median we just saw in there is 13.5. All right. Now, for finding Q1 and Q3, that's also, we don't have that in Desmos. So a couple things we can do, we can create a box plot in Desmos, or we could find the Q1 and Q3 right here by hand. Let's see what it would look like on Desmos. So you're going to go through and use the function but distribution this time and get box plot, and then type in x1. And what we'll see here, then you hit the zoom to make zoom fit, and we will see that we get this box plot here. And when we zoom in on it, we can see that we have Q1 is at 8, and Q3 looks like it's at 17. Get out of the way. Q1 was at 8, and Q3 was at 17. And now I can find the IQR by doing Q3 minus Q1, which is 17 minus 8, so that's 9. My range is max minus min, that's 15, 20 minus 5. And I can use that to make my box and whisker plot here, where I have my min and my max. My Q1 is at 8, 5, 6, 7, 8, 17, and then 13 and a half, 10, 11, 12, 13 and a half right there. And so there's our box and whisker. So below this, you'll see problems 1 and 2. After the video, you can go back and kind of model this, model 1 and 2 off of how we did A and B. Moving on to the next page. With problem C here, we start to get into the interpretation of the box and whisker plot again. And so one of the biggest things to remember is that each little kind of section, if you look at the box and whisker plot, it's divided into 4 sections. Those are the 4 quartiles. Right, we have, and I'll write them out here, we have the min to Q1, and then you have Q1 to the median, then you have the median to Q3, and you have Q3 to the max. Each of those sections represents 25%. of the data, or approximately 25% of the data. So on this graph here, and I'm going to zoom in real close for a second, on this box and whisker plot, I know that this section is 25%. And so is this section. And so is this section. And so is this section. Right? So each of those little sections, the two whiskers are each 25%, and the two sections inside the box, inside the interquartile range, are each 25%. So this is number of different shows watched over the last month, so a bunch of kids were surveyed. So use the box plot to determine what percent of the data falls between 3 and 9. Well, if we know these 25% chunks, this becomes a super easy problem. Right? We just do the math here. So between 3 and 9, that looks like it's my min to my median. So that's 50%. 50% of students are between 3 and 9, have watched between 3 and 9 different shows over the last month. So 5 and 18. Okay, so you find 5, all right, that's right there. 18 is right there. So that goes two sections, 25%, 25%. That's also 50% of the data. 18 to 20. That's the right whisker. 18 to 20, that'd be 25%. 3 and 20, well, that's the minimum to the maximum. That's everybody. That's 100%. And 20, between 20 and 22, well, there's no data there. There are no students who watched between 20 and 22, so that's 0%. In the second section here, part D, we have, using the box plot from part C, fill in the blanks with the correct value, or if it's not possible to determine, write not possible, or NP. So the median. Well, a box and whisker plot does show us the median. It's that middle bar of the box, so the median is 9. The mean. A box and whisker plot does not show us the mean, so that's what's not possible. We don't know what the mean is. We could kind of maybe estimate, not really though. The minimum, yes, I can see the minimum. It's 3 at the very end here. The range, sure, I could calculate the range because it's the max minus min. So that's 20 minus 3, which is 17. Standard deviation, no, I cannot calculate this from a box and whisker plot. Not possible. We can see that the data is spread out, but we don't know what the standard deviation is. And in part E, still using the box and whisker plot, we have some questions to answer. So the first one is, what specific values do you know are in the data? The minimum. Essentially, that's saying, is there a student who watched 3 different shows over the last month? And because that's the minimum, we know that's yes. That's the minimum value of this data set. So yes, there has to be a student who watched 3 shows. Q1. Well, Q1 we know is 5. Do we know there's a student who watched 5 shows? Because I'm looking right up here. No, we don't. Q1 could be like a median of between 2 numbers, so no. Same with the median, right? And I guess what I'm trying to say is, remember with your data sets, if we had a data set that was 4, 8, 12, and 20, the median would be 10, but there's no, 10 is not a value in the set of data. So the median, Q1 and Q3 aren't guaranteed to be values in the set of data. So that's a no, and Q3 is also a no. But the max has to be, in this little example, the max is 20. It has to be. So yes. So only the minimum and the maximum are guaranteed to be in the data. How many students said they watched 9 shows? Well, here's 9, that's the median, but we don't even know how many students they asked. So there's no way we could know. A box and whisker plot doesn't show us that. We don't know for 9. How about how many students said they watched 0 shows? Well, even though the box and whisker plot doesn't tell us about specific numbers of students, I can answer this one because the minimum was 3, so none. We have no students watched 0 shows. All right, once again, problem 3 here follows similar to this, so try that one out later. Let's move on to the next page. So F, G, and H here have to do with these test scores, and they are Mr. Bieber's class. And for the first part here in F, some of these are answered for us. Great. Okay. We've found all the information from the 5-number summary that's given to us. Mean, mode, we're missing that. We have standard deviation, range, and IQR. So what I want you to do is pause the video and take just a minute to figure out the mode, the range, the IQR, and draw a quick box and whisker plot. All right, there you go. See how you did. In part G, now we're going to just do a little bit of analyzing here. So Mr. Bieber realized he'd graded some problems wrong. So each student's getting 3 more points. Explain what happens in the mean, median, mode. All right, so let's look. We've got the mean was originally 46.5. Median originally was 47. And the mode was, we found it was 47. Oh, I'm sorry, I messed that up. No, the mode is 47 also. Okay. And so if I add 3 points to everybody's score, well, now the average score is going to go up 3. And we saw this in an earlier video. So that would be 49.5. Right? Every data point here is getting shifted up 3. So the median is going to get shifted up 3 also. So that's 50 is the new median. And all 4 of those 47s that make it the mode, all their scores are now 50, 50, 50, 50. So that's 50 is going to be the biggest score. So look at that. All the data points go up by 3. Or all the measures of center, mean, median, and mode go up by 3. Okay, then in part H, Mr. Bieber is now upset at his entire class and decides to give each student only 50% of their earned points. Not very good teacher. Explain what happens in the range and standard deviation. All right, so this is a little tricky. But again, we saw this in an earlier video. If we doubled every score, now the scores are going to be more spread out. So if we cut every score in half, they're going to be actually less spread out. And so my old range was 17. To find the new range, well, let's look. What's the smallest score going to change to? It's going to go from 37, cut it in half, and that's going to be 18.5. And then the biggest score is 54, cut that in half, and we get 27. So my new range is going to be from 27 to 18.5, which is 8.5. Oh, is that half of 17? Look at that, it is. Okay. The old standard deviation was 4.95. Well, a pretty good prediction would be that standard deviation would get cut in half. And I'm not going to have you go through and actually do this. It is, if we were to go type in all those data points and cut them in half, we would see that the new standard deviation would be half of it, about 2.48, which is rounded in half. And so the measures of spread are cut in half because the data is half as spread out. All right, one more set here. All right, last page, we're almost done. We've done these before, so I'm gonna go through them quickly. If you wanna pause and try them on your own, go for it. So we wanna find the missing data point. I want the mean to be 32. So in this case, I gotta add everything up and divide by 1, 2, 3, 4, 5, 6 data points, and my mean should be 32. So we've set the equation 19 plus 25 plus 29 plus 30 plus x plus 46 all over 6 should equal 32. That's how you find the average. Okay, so then I'm going to add up all those stuff on top. In other words, combine those like terms, and we get 149 plus x over 6 equals 32. to solve this, I gotta multiply both sides by 6. We get 149 plus x equals 192. And then I subtract my 149 from both sides, and we get 43. Problem B, I want to find x, so the median is 300. And so I noticed that my median, there's 6 data points, so the median should fall there, somewhere between 275 and x. Well, I'm told it's 300, so I need x to be the number that makes the median 300. Well, I mean, I like to think about it, these two numbers we kind of average together to get 300. And the way to really think about this is 275 is 25 away. So I subtracted 25, so I gotta just add 25. And to do that, we get x equals 325. Right? That'll give me a median of 300, because the average of 275 and 325, halfway between them, is 300. C, I want the mode to be 19. Well, that means it's the most common number, so I just need x to be 19. Last one, range is 40. Well, if my biggest number is 90 and I want the range to be 40, I need my smallest number to be 50. So x equals 50, because that would be 90 minus 50 gives me a range of 40. That's all. Thanks for watching. Good luck with all the problems we didn't do. They're similar to the ones that you see on here.